Hi everyone, thank you so much for coming to this video. So today we're going to be going over trig equations. So please review all the lessons we've done on the trig identities and the R addition formulae and also the double angle formulae, as they may all come into useful for this video. So the learning objective for today is going to be able to solve trig equations in a given interval. I'm going to be taking you through 2 exam questions to show you how to apply everything we've done so far to solve an equation. So like always, there will be timestamps in the description of the video, so feel free to skip to any parts you want to. But let's get started. So we have an exam question here. Feel free to pause the video and try it out for yourself first. So we want to solve for between 0 and 180 degrees. 2 cot squared 3 theta is equal to 7 cosec 3 theta minus 5. So we want to give our answers in degrees to 1 decimal place. So the first thing you need to recognise with this equation is that they're involving a mixture of tan and sine, which we can't have. So we want to try and see if we can use an identity maybe to sub one of them in terms of the other. So if you remember from the trig identities, one identity is that 1 plus cot squared x is just equal to cosec squared x. So that means, so we can rearrange this identity to get cot squared x is just equal to cosec squared x minus 1. So now we can just plug in this identity into our equation. So we would get 2 times cosec squared 3 theta. So we're using x is 3 theta minus 1 is just equal to 7 cosec 3 theta minus 5. So now we just want to expand our bracket. So we get 2 cosec squared 3 theta minus 2 is just equal to 7 cosec 3 theta minus 5. And now we can just rearrange to get an equation that's equal to 0. So we would get 2 cosec squared 3 theta minus 7 cosec 3 theta minus 2 plus 5, so that's just plus 3 is equal to 0. And now we can do solve this quadratic equation using substitution. So we could say that y is just equal to cosec 3 theta. So then we would have 2y squared minus 7y plus 3 is just equal to 0. Then if we factorize this, we would get 2y minus 1 and then y minus 3. And that should just be equal to 0. So then we can solve each of them individually. So if we sub in y as cosec 3 theta, so that means we'll get 2 cosec 3 theta minus 1 is equal to 0. So then cosec 3 theta is just equal to a half. So that's one of them. And then if you remember the definition of what cosec is, that's just the reciprocal of sine x. So cosec 3 theta is just the same as 1 over sine 3 theta, and that would be equal to a half. So now if we cross multiply, we would get 2 is equal to sine 3 theta. So then for this one, if you remember what the graph of sine x is, that just goes like this, with this being 1 and this being minus 1. And if the graph is sine 3 theta, then that means it's just squished in the x direction by a third. But that means that this value, which is 180, that may squish to go to 60, but your maximum minimum of 1 and minus 1 would stay the same. So sine 3 theta will never equal 2. So there's no solution for this one. So now if we move on to here, so we have cosec 3 theta, that's just equal to 3. And if we say cosec 3 theta is just 1 over sine 3 theta is just equal to 3. And if we cross multiply, we'd get 1/3 is equal to sine 3 theta. And that does work because it's the sine 3 theta is between 1 and -1, so we'll have a solution for 1/3. So now we can just take the inverse of that. So we could do, for now, let's just call 3 theta is equal to z. So we can just solve for 1/3 equals sine z. So then z would just be equal to the inverse of 1/3. So now if you plug that in your calculator, you should get that z is just equal to 19.5 degrees. And now it's asking between 0 and 180. So you'd have one here, one solution here, and you would also have another solution here. So if you do 180 minus 19.5, you would also have a solution at 160.5 degrees. So now as z is equal to 3 theta, we can work out what theta is. So we can just do these values divided by 3. So if we do 19.5 divided by 3, we'll get 6.5 theta. If we do 160.5 divided by 3, we get 53.5 theta. But that's not all the solutions. There will be more. So if we continue this graph like this, let's see if there'll be more. So this crosses at 360, and this would cross at 540. So we'd have another solution for 1/3 here and here. So this was at 19.5. So the next one would just be at 360 plus 19.5. So it'd be at 379.5 degrees, and the other one would be 540 minus 19.5. That would just be 520.5 degrees. And then if we divide each of them by 3, we get the first one, 379.5 divided by 3. That would just be equal to 126.5 degrees. And the last one, if you do 520.5 divided by 3, you would just get that is equal to 173.5. And you know now that because it's only between the largest value that theta could be is just 180. So if you continue to get more than 180, so we stop there. So these are your 4 solutions to the question, and we just want them all to 1 decimal place, which is what we've given. So yeah, so it was 10 marks, so it was a lot to do just for one question. So but if you think about it, all we did was we just had to notice that we needed to find out what this identity was and sub that in. And then we just had a quadratic equation that we could solve. And then you just have to make sure to draw out your graph again, just to make sure you get all the solutions. And you remember that we're dealing with 3 theta. So if you remember that 3 theta, the graph is just squished in the x direction a third. So it means that you are going to get more solutions. So now let's try another one. Okay, so I have another exam question here. So feel free to pause the video and try it out for yourself. So we have fx is equal to 7 cos 2x minus 24 sine 2x. And the first part is we want to find the value of r and the value of alpha. So if you remember from what we were doing on the r addition formulae, the first thing you want to do is you just want to expand your r cos 2x plus a. So if we expand that, so we get fx, which is just equal to r cos 2x plus alpha. That would just be equal to r cos 2x cos alpha minus sine 2x sine alpha. And that's just using your addition formulae. So if you've forgotten that, make sure you either look up the formula or go back to that video. And then your next thing is you just want to match up your coefficients. Here we have, instead of having cos x and sin x, we have cos 2x and sin 2x, but we can still match them up because in our fx here we have cos 2x and sin 2x. So we have our coefficient of cos 2x, that's just our cos alpha, and that would just be equal to 7, and then our coefficient for sin 2x is just r sin alpha, and that's just equal to 24. So now we can just, first thing, we can just work out alpha from this. So if we do r sin alpha over r cos alpha, that would just be equal to 24 over 7. Then we can cancel this out, so we'd get tan alpha is just equal to 24 over 7. So then alpha is equal to the inverse of tan of 24 over 7, which is also just equal to 73.7 degrees. So that's alpha. And now if we were to find what r is, r squared, if you remember, it's just equal to the square root of 7 squared plus 24 squared, which is just equal to the square root of 625, which is just, so that's just meant to be r, and that's just equal to 25. So therefore we have fx can also be written in the form of 25 cos 2x plus 73.7. So that's your answer to the first section. Now if we move on to part B, so we want to hence solve the equation 7 cos 2x minus 24 sin 2x is equal to 12.5 for 0 between 0 and, so to do that we can, now we've got what the form of this is in terms of the R formula, we can just rewrite that as 24 cos 2x plus 73.7 is just equal to 12.5. So now we want to solve that. So if we divide both sides by 25, we get cos 2x plus 73.7 is just equal to 0.5. And if we do 2x plus 73.7, that would just be equal to the inverse of cos of 0.5. So that would just be 2x plus 73.7, that's just equal to 60 degrees. But then if you draw out the cos graph, so this would be 90 and this would be 270. This is 1.5. You also have another solution. You have one solution here which is 60, another one here. So 90 minus 60, that's just 30. So if you do 270 plus 30, you'd also get 300 degrees. And let's see if we can do more, because we might have another solution that might come in handy. If we bring the graph down, then you know that the other time it will cross the graph would be at 450. So now if we do 450 minus 30, we'd get another solution for 20 degrees. So now we would just want to write 2x is equal to all of these minus 73.7. So for the first one, you would get a negative value. So we can just ignore that because we only want it to be between 0 and 180. So now if we do 300 minus 73.7, we should get that's equal to get 226.3 as one solution. We'll also get 420 minus 73.7, which is just another solution as 346.3. And now if we just divide it all by 2, we'll get 226.3 divided by 2, so that's one is 113.2 degrees, the other one 346.3 divided by 2, that will just be 173.2 degrees, both to 1 dp. So and if you see that if we did have another value, that wouldn't work, as our next value would just be larger than 180, so we just stop there. So yeah, that's your answer to this next question. Again, it's just remembering how to use the R addition formulae, and then we can just solve that to find our values of x. So just remember that there's always going to be, most times going to be more than one solution, so make sure you do draw out the graph. And because it's 2x first, then you know that you're going to need to go beyond just the 180 to find the solutions, and then you can just solve it normally and divide by 2, and just make sure that all your final answers are in the range that they give you. So that's everything. Hopefully you found this useful and you now know how to solve some trig equations in a given interval using everything that we've applied, that we've learned previously with the R addition formulae, trig identities, double angle formulae. All these can come in useful when solving trig equations. So make sure you do lots more practice just to make sure you're fully comfortable at doing this. But other than that, thank you.